MTBF, mean time between failures. MTBF tells us how much time, on average, passes between failures. In other words, it tells us, on average, how frequently a piece of equipment breaks down. As shown on the slide, let's imagine a machine started operating. It worked for 120 hours before it failed. After the repair, it ran for another 110 hours until the next failure occurred. When we use the MTBF formula, we add 120 hours and 110 hours and divide the result by 2 because we observed 2 failures during the considered period. That gives us an average time between failures of 115 hours. So MTBF is simply the total operating time divided by the number of failures. How should we interpret this value? The higher the MTBF, the more reliable the equipment is. A low MTBF might suggest that preventive actions are needed, or that the equipment is approaching the end of its useful life. What does MTBF really mean? MTBF, or mean time between failures, is one of the most frequently used, but also one of the most commonly misunderstood reliability indicators. In practice, it represents the average time a device operates between failures, provided that the failure can be repaired. For non-repairable equipment, like a light bulb, we use a different measure called MTTF, mean time to failure. MTBF also assumes that failures are random. It does not take into account the effects of aging or wear and tear. In other words, MTBF applies only to the middle part of the so-called bathtub curve, the useful life period of equipment. It doesn't reflect issues that occur during the early infant mortality phase, right after a machine is introduced into service, nor does it consider the wear-out phase later in its life cycle. It's also important to remember that MTBF does not represent the expected time to failure. In fact, statistically, about 63% of devices fail before they reach their calculated MTBF value. What many people don't realize is that MTBF has military origins. It was developed in the 1940s in the United States, when the military needed a method to assess the reliability of radars, aircraft, and electronic systems. Later on, it was adopted by industry, but it still relies on the assumption that failures occur randomly and are not age-related. MTBF was later formalized in military standards such as MIL HDBK 217, first published in 1965. The most widely referenced version, MIL HDBK 217F, appeared in 1991. How to use MTBF wisely. MTBF can be a useful metric, but only if we understand its limitations. It works well for comparing devices operating under similar conditions. It's also helpful when monitoring the effects of changes. For example, if MTBF increases after preventive actions have been implemented, that's a good sign. It can also assist in selecting new equipment, but only if we compare similar machines and know how the manufacturer has calculated the MTBF. However, never treat MTBF as a goal in itself. It is only a supporting tool for decision-making, not an oracle. Misunderstanding or misusing MTBF can lead to serious costs and poor decisions. This material is an excerpt from the course Maintenance Mastery. Want to learn more? Visit rcm2.org.